Today we will discuss about transport phenomena basics. So in this transport phenomena basics, we will discuss about the first of all assumptions, how the assumptions plays important role to solve the transport phenomena problems. So if you go to the index page B3, B4, B5, B6, which are there in end of the book of Bird, new edition. So in this book you can find out the equation of continuity and equation of motion and equation of energy balances. So we will see one problem regarding this equation of continuity and equation of motion, how we can apply for this problem. So consider a problem. So in this problem, one horizontal tube is there, horizontal pipe, you can assume horizontal pipe. If the flow is only in x direction, so it's z direction, flow is in z direction, and r is radial direction, and theta is the angle of tangential flow. So the theta can be viewed from front view like this. So in this problem page number is 88 in book, example is 3.61. so in this problem what they give, the horizontal tube length is L and pressure drop is P and constant rho and mu viscosity. So finally they told that the flow is always existing in z direction only. So z direction with respect to z always will be 0. So remember this point, and always the z flow can be measured with respect to r. So remember this point also. So consider equation of continuity. So in this equation of continuity, dou rho by dou t, so you can write down this equation from the index, dou r into rho r plus 1 by r into dou by dou t into rho v theta plus dou by dou z rho of v z equal to 0. So here we consider that it is a steady state flow which is given in the problem. The problem heading itself, steady flow in horizontal circular tube. Steady flow in horizontal circular tube. So itself states that with respect to time, steady flow means with respect to time no change. With respect to time no change, that implies dou rho by dou t is equal to 0. So you can directly assumption as 0. This arrow mark indicates that it is a 0, and in VR direction the velocity is not there, so flow is not there, VR is not there, and tangential direction also not there. So VR also will be 0, V theta will be 0. Then finally what we got is dou by dou z of rho of Vz equal to 0. Here we previously said that rho is constant. Then finally we got dou Vz by dou z equal to 0. Finally this indicates that dou Vz by dou z equal to 0 means the horizontal flow which is in z direction with respect to the dou Vz with respect to z direction is 0. So remember this point will be useful for further. So coming to the equation of motion. So in this equation of motion there will be 3 will be there. One is r, theta, z. In our case dou into dou Vr by dou t plus Vr into dou Vr by dou t plus Vtt by r into dou Vr by dou t plus Vz into dou Vr by dou z minus V square theta by r equal to minus dou p by dou r plus mu into dou by dou r of 1 by r into dou by dou r of r into Vr plus 1 by r square into dou square Vr by dou theta square plus dou square Vr by dou z square minus 2 by r square dou veta by dou theta plus rho g theta. So don't worry, this will be given in the data book which in the final end examination. So this is regarding the r component of the whole equation of motion. So we previously know that Vr equal to 0, V theta equal to 0. So 0 that terms Vr, here Vr, and here V theta is there, and Vz, here Vr is there, so this will be 0, and V theta this will be 0. And same thing similarly Vr 0, and dou Vr by Vtt is not there, Vr is not there, Vθ is not there. There is no gravitational force. Why? Because of this is a horizontal one, there is no acting gravitational force. So finally we come to the conclusion that minus dou P by dou R equal to 0 from R component. So in second one we will come to the theta component. In this theta component, rho into dou Vθ by dou T plus Vr into dou Vθ by dou R, Vθ by R into dou Vθ by dou T, Vz into dou Vθ by dou Z plus Vr into Vθ by R equal to minus 1 by R into dou V by dou T plus mu into dou by dou R into 1 by R into dou by dou R of R into Vθ plus 1 by R square into dou square Vθ by dou theta square plus dou square Vθ by dou Z square plus 2 by R square into dou V R by dou theta plus rho into zeta. So in this also dou Vθ is not there, dou Vθ is not there, dou Vθ is there, and dou Vθ is not there. Here also dou Vr, dou Vθ also 0. So in coming to this, here also Vθ is there, Vθ is not there, Vt is not there, Vr also not there, rho is not there, it's 0. So finally equation is 1 by R into dou P by dou T equal to 0. So R equal to 0, then finally dou P by dou Tt equal to 0. So finally from the equation of 2 we can get this. And third one is for Z coordinate. So Z coordinate regarding, so we write rho into dou Vz by dou T plus Vr into dou Vz by dou R plus Vθ by R into dou Vz by dou T plus Vz into dou Vz by dou Z equal to minus dou P by dou Z plus mu into 1 by R into dou by dou R into R into dou Vz by dou R plus 1 by R square into dou square Vz by dou theta square plus dou square Vz by dou Z square plus rho into Gz. So here also it is a steady state, Vt will be 0 and Vz by Vr, this will be 0 because of Z with respect to R is not there, Vθ is there, so 0, Vz is there, Vz by this is 0, we get in already in equation of continuity, so this also is 0. So dou by dou Z is there and dou Vz by dou R is there. Why? Because of the flow Vz we will study with respect to the R, and dou Vz by with respect to theta 0 and Vz by Vz with respect to 0, this is also 0. So finally what we will get is dou P by dou Z plus mu into 1 by R into dou by dou R into R into dou Vz by dou R equal to 0. So finally what we will get is mu by R into dou by dou R into R into dou Vz by dou R equal to dou P by dou Z. So here finally you need to calculate these two terms, and here variables is dou P is there, dou Z is there, dou R and is there. 3 variables is there. So what I will do is mu by R into dou by dou R into R into dou V by dou Z, dou R equal to I will consider as C naught, and at the same time dou P by dou Z equal to C naught. So if I integrate this dou P C naught into dou Z, integrate in both sides, then finally integrate and dou cancel, P equal to C naught, and here also cancel, and dou Z will become Z plus C1. So this is the one, and here second one mu into dou of R into dou Vz by dou R equal to C naught into R into dou R. So if I apply both side integration and dou will cancel, so mu into R into dou Vz by dou R equal to, here also dou and integration means C naught into R square by 2 you will get, so plus C1 already used, so we can use C2, and again we will apply for integration dou Vz integration and C naught into R square by 2. We will make the mu here before in this step itself. So here itself you will do mu here. So this, and again this R and dr will be go here, R and dr plus C2 into dr. This will be by, so the integration will be cancelled and Vz equal to, so R will be cancelled, and here also integration, here also integration. So here C naught into 2 mu into R will be there, r gives rise to 2r square by 2 plus c2 into log r plus c3. So finally we will get Vz equal to c0 into r square by 4 mu plus c2 into log r plus c3. So this is half of the problem is over. The final thing is you need to apply the boundary conditions. Finally you get the result, which they need is a velocity profile in terms of y and t, I think. So this is the first video. If anything is there, criticize me. I will change or I will improve it. I am only a technical literate, not expert in this subject. Thank you.